Okay, we are going to be talking about circles today. So first of all, I want to show you where the equation from a circle comes from. And it actually comes from the distance formula. And you see the distance formula right here, and we've already used this year, and you learned this in geometry as well. The distance formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. And our equation for a circle actually comes from this. So if we take a look at a circle, we say that circles have a center called HK. Where does HK sound familiar from? Translations, yes. So HK is your center, and XY is any point on the circle, okay? If we put these into the distance formula, using the x2 minus x1, x2 is x, x1 is the h, y2 is the y, y1 is the k. So now we have x minus h quantity squared plus y minus k. And that distance from the center of the circle to any point on the outside of the circle, would you agree that distance is the radius, right? That's the radius of the circle. So we say that equals r. Well, we don't want that square root there, so we're going to square both sides to get rid of it. Square here, square here. That squaring undoes the square root and gives us an r squared. This is the equation for a circle. So I'm going to highlight it here in our little box. X minus h squared plus y minus k squared equals r squared. And r is the radius, h and k are the center. All right, so it's a pretty simple formula, and my understanding is you guys are doing this literally like today in geometry.
Yeah.
Double whammy. You know what you're doing. So let's go down here to the bottom of the page. And we have, what is the equation of a circle with the center of -4, 3, and a radius of 4? So keep in mind, this is h, this is k, and this is r. All right, so we're going to put this all into our formula. So our formula is x minus h, which is going to be x minus -4, which gives you x plus 4 squared. Y minus k, k is 3, squared, equals r squared, which is 4 squared. All we need to do is square that 4. That's going to give us x plus 4 squared plus y minus 3, quantity squared, equals 16. So let's go ahead. We can do the next one, right? Let me give you a second. See if you can put this together. Doing it just like we did the last one. All right, so x, what? Minus 5. Quantity squared, plus y, what? Plus 2. Quantity squared equals what? 64. Beautiful. Not too tough, right? This is not too tough. Okay, flip the page. Okay, now we're going to do a little bit of translation. Remember, h and k being the center still represent a translation, because usually that center is at 0, 0. In an equation like this, the center is 0, 0. But if we're going to shift this 4 units to the left and 3 units up, what is my new center? 4 units left, 3 units up. -4, 3. So h, k is -4, 3. All right, and remember how we said this. 4 units left is going to be plus, right? When we go to the left, we're going to add, and 3 units up. All right, so we have x plus 4, quantity squared, plus y minus 3 quantity squared equals 9. Now the one weird thing is when we always did this, we always had the y on a different side, right? When we did translations, our y was over here by itself. And so if we did 3 units up, it was adding plus k, right? And notice this k is positive, but we're subtracting it, right? It's because it's on the same side with the y and not on the other side. That's why. All right? So the sign thing is going to be the same as it is for h. Okay, transforming a circle. You can use the parameter r to stretch or shrink the unit circle. So x squared plus y squared equals 1. That's the unit circle because it has a radius of 1, right? Makes sense? And its center is 0, 0. To the circle x squared plus y squared equals r squared with the radius of r. So remember how we had shrinking and stretching? That all happens through r. All right? We don't stretch this way into an ellipse. The circle just either gets bigger or smaller, and that's all impacted through r. All right? Let's do this. Let's go down here to example 3. Which equation models the circular irrigation field here? So there's a couple of things we need to identify. Identify the center, which is HK, and the radius, R. That's what we need to know. So looking at this picture, which looks like a big agricultural field out there in the world, what's the center? 450, 500. Right here. And what's the radius? 400 feet. All right. So would you agree it's not too tough to write an equation for this circle from this information, right? X minus h, so x minus 450 quantity squared plus y minus k, so y minus 500 quantity squared equals 400 squared, right? Let's get a calculator out here. 400 square that, 160,000. There we go. So now you wrote an equation from being given a center and a radius, and you wrote an equation from a picture. All right? Let's get to some more challenging stuff. Fun, fun, fun. Okay. Take a look at these equations and tell me, in example A, what is the center?
16 and negative 9.
16, negative 9. What is the radius?
12.
Radius is 12. Do you see where the radius is 12? The square root of whatever is over here, because this is r squared. All right, this is your h, this is your k. Now, if you take a look at B, this is quite different, right? This is cool. I got a couple examples of this. This on your homework is like number 60 and 61. These are cool. This will be a little bit more of a challenge, but these are the ones I think are fun. Notice, these are not written as x minus h quantity squared and y minus k quantity squared, are they? Okay, you're going to write them that way. Here's what you got to do. You're going to put all the x stuff together and all the y stuff together. So we're going to take this and we're going to actually rewrite it with the x stuff together and the y stuff together. So take a look at this. This is x squared plus 8x. Leave a blank. All right? Plus y squared, whoops, minus 10y plus a blank.
Have we done this before?
Nope. But it's very much like something we did. In order for us us to write these x terms in this kind of format. We have to do completing the square, don't we? Remember completing the square? We did this when we did quadratics. So, remember our formula? Our new C equals B over 2 quantity squared. So right here, our new C equals 8 over 2 quantity squared, which equals 4 squared, which equals 16, right? Okay, and we were going to do it like this. We put the 4 squared here, and we're going to add 16 over here. Remember doing that from completing the square? Let's do it again. We got to do it for the y's anyway, so let's go over here and we'll do it in purple for the y's. This is C. So C equals negative 10 over 2 quantity squared, which equals negative 5 quantity squared, which equals 25, right? So right here we put plus negative 5 squared, and on this side we put plus 25, right? Do you remember what we did? We could take this, and this became x plus 4 quantity squared. And this became y minus 5 quantity squared. And then over here, I've got 8 plus 16 plus 25 gives me 49. So now I can tell you what the center and the radius are, right? What is my center? Yes, negative 4, 5. And what is my radius? Beautiful. Completing the square. It's kind of like double completing the square. Complete once for the x's and once for the y's.
I like this.
It's not too bad. We did this before. We can do this. One last thing that we're going to cover before I'm going to let you start working on your work. We are going to graph. All right, so go down to the bottom of the page, and we're going to graph this. This is not too bad. So first of all, looking at this equation, what is the center? Okay, so our center is negative 1, 3, and what is our radius? Our radius is 5. So let's go to the point negative 1, 3, right here. Okay, let me tell you how you're going to do this with radius 5 without having yourself what do you call those things? Compass? Or is it a protractor? I don't remember which one's which. Okay, it's a compass. So radius is 5. So go this way 5 units, put a point. Go this way 5 units, put a point. Go up 5 units, put a point. Go down 5 units, put a point. Those are all points on your circle. So now you're going to try and draw your circle really, really neatly. So not too bad, right? Freehand, not too bad.
Where's your stencil?